Welcome everyone to BTT 151 Fundamentals of Electricity. I would like to go over your Unit 5 homework. Question 1. Series circuit has individual resistor values of 200 ohms, 86 ohms, 91 ohms, 180 ohms, and 150 ohms. What's the total resistance of the circuit? So in a series circuit, the equation is equivalent resistance, R equivalent, is equal to, add up all the resistor values, R1 plus R2 plus R3 plus R4 plus R5. So if you add all those values up, you will get 707 ohms. Question 2. Series circuit contains 4 resistors. The total resistance of the circuit is 360 ohms. 3 of the resistors have values of 56 ohms, 110 ohms, and 75 ohms. What is the value of the 4th resistor? So in this example, the problem is giving you R equivalent. So we just have to play a little game with algebra. So now R4 is going to be equal to R equivalent minus the sum of R1 plus R2 plus R3. So if you plug the numbers in, 119 ohms. Question 3. A series circuit contains 5 resistors. The total voltage applied to the circuit is 120 volt. 4 resistors have voltage drops of 35 volts, 28 volts, 22 volts, and 15 volts. What is the voltage drop of the 5th resistor? So again, in a series circuit, the sum of the voltage drops in the circuit have to equal what's called the voltage rise, or the battery, or the supply voltage. So we're going to play a game in algebra again. This time, voltage across resistor 5 is going to be equal to the total voltage minus the sum of the individual voltages, VR1 plus VR2 plus VR3 plus VR4. Plug those numbers in, you'll get an answer of 20 volts. Question 4. A circuit has 3 resistors connected in series. The resistance of R2 is 220 ohms, and it has a voltage drop of 44 volts. What's the current flow through resistor R3? So again, remembering rules for series circuits, in a series circuit, the sum of the resistors equal a total equivalent resistance value, Req. The current is the same through each resistor, and the sum of the voltage drops have to add up to be equal to the voltage rise or the battery voltage. So in this case, we know the voltage drop across resistor 2 is 44 volts, and we know the value of resistor 2 is 220 ohms. So using Ohm's law, I is equal to V divided by R. 44 divided by 220 gives us a current of 0.2 amps. Question 5. Circuit has 4 resistors connected in series. If each resistor has a voltage drop of 60 volts, what is the voltage applied to the circuit? Each resistor value has a voltage drop of 60 volts. There's a quantity of 4, so we simply have to multiply 60 times 4. 240 volts would be the total applied voltage. Question 6. Define a series circuit. One path for current to flow. We're going to see in Unit 6, parallel circuits, we're going to have multiple paths for current to flow. Question 7. State the 3 rules for series circuits. The current remains the same. The resistor, the equivalent resistance value, Req, is equal to R1 plus R2 plus R3. For example, how many resistors are in the circuit. And the third part, the sum of the voltage drops have to equal the voltage rise or the battery voltage. So you simply add up all the voltage drops and they have to total the supply voltage. Question 8. A series circuit has resistance values of 160 ohms, 100 ohms, 82 ohms, and 120 ohms. What is the total resistance of this circuit? So again, all we have to do is add up all of the resistance values. R equivalent is equal to R1 plus R2 plus R3 plus R4. Plug the numbers in and you'll get 462 ohms. Question 9. If a voltage of 24 volts is applied to the circuit in question 8, what is the total amount of current flow in the circuit? So using Ohm's law, I is equal to V divided by R, voltage supply or total voltage is 24 volts. The equivalent resistance we just calculated from question 8, 462 ohms. So 24 divided by 462 gives us a current of 0.052 amps. And lastly, question 10, what will be the voltage drop across each of the resistors? So we're going to put the 4 resistors back in series. We know, we just calculated in question 9 what the actual current flow was. So remember, in a series circuit, current is the same. So we're going to take that 0.052 amps and multiply it by the value of each resistor. So the voltage drop for R1 will designate VR1 is 8.32 volts. The voltage drop for resistor 2 will designate as VR2 is 5.2 volts. The voltage drop for resistor 3, that's designated VR3, is 4.26 volts. And the voltage drop across R4, that will designate as VR4, is 6.24 volts. So again, since the current in a series circuit is the same, we should be able to add these values back up to equal the battery voltage. So 6.24 plus 8.32 plus 5.2 plus 4.26 should equal that 24 volt supply. Thank you.